color is very limited. So in the case of semiconductors, but if you make QDS quantum dots, we can able to tune various colors. So that's why we people are interested these quantum dots in LED displays, smart displays, even in solar cells or whatever the smart technologies we want. So there we can use the quantum dots materials, because it can able to emit different colors and easily we can tune out on each colors. So that's what the interesting of quantum dot based solar cells. And of course the quantum dot based solar cell have many advantages. It is very easily and very flexible kind of solar cells can be able to make through these quantum dots. And compared to the conventional solar cell, the power weight and the power consumption is vary. But however, for flexible and making of solar cells, quantum dot is best. But that's what the main interest about this quantum dots. And using of this tunable wavelength, particularly each wavelength can be easily tunable with the help of quantum dots, so that these materials can be used in the smart displays, LED displays, etc. So it is this is also related to the quantum physics or photophysics. So photoluminescence or luminescence. So generally in basics, as we know that there are many type of luminescence. So the biological luminescence is start from periphery. The small insects have can able to microorganism have ability to luminescence the light, called bioluminescence. And chemical ligands plays an essential role for chemiluminescence. And photoluminescence, the source of excitation is photons, and phosphor materials will be used. And similarly there are other luminescence, radioluminescence, radioactive materials plays an important role. And thermoluminescence, just emission as a result of heatings. So this is basic mechanism can be explained by this luminescence property. It will be molecules as getting a relaxation. So after this insect in the energy, and this energy was moving into the upper energy level, and it's moving to that, and then after comes down in the lower energy state, it releasing it. So the molecules get relaxation while coming down from the excited state to this ground state level. So when the ground state level, the relaxation of an radiative way, and another one is the non-radiative way. So non-radiative way in the terms of heat energy, and the radiative way is in terms of photonic energy. So this photonic energy, I will make it as two different ways. One is the fluorescence, and similarly the phosphorescence. So this phosphorescence, while coming in the excited state to this comes down in the lower energy state. So the energy levels are splitting off. One is the singlet ground state, and then the single excited state. And after moving of excited state to comes down here, then and making of smart QLEDs. Then as I told that the bioimaging also can be used quantum dots. And recently the sensor can able to do detecting of biosensing of molecules or chemicals. For sensing of chemicals or biomolecules, the quantum dot sensors will be useful. And also making a flexible device in the solar cell. And quantum dots in recent days, smart displays like the future computer, which we can able to see here. So there is a Google Glass, smart glass is going to be coming in this market very soon. But already in this market, actually 1 or 2 companies are start producing of Google Glass, smart glass. So here the displays are made up of quantum displays, QD displays. So why QD displays? And for that we need to compare the evaluation of efficiency compared to the light. So if we know this, then we can understand what is the strength of QLEDs. So now let's discuss the earlier one is a lifetime under the efficiency of tungsten lights. So this is the initial state. So the lifetime in hours of 800 and the efficiency is 8 to 10 luminescence per watt. And similarly, the halogen lamp have increased 5,000 lifetime hours, 5,000 hours lifetime, and the efficiency of luminescing per watt is 20 to 30. And the CFL chlorofluoro light efficiency is 5,000, and the efficiency was ultimately increased from 50 to 60. So that in the market, the CFL bulb was very powerful, but the problem is the CFL bulb is the chlorofluorocarbon is highly toxic in the environment. So that people are moved into this LEDs light. So in this LED light, people are used to more than the 5,000. It's more than of CFL bulb. So the lifetime is so highly increased, and the efficiency is luminescing per watt is 60 to 80. So it was increased lot. And also when the efficiency is increased, so obviously there will be a power consumption. So we can able to reduce the current bill less. Okay. So that's what people are making of LEDs. And now in all the smart electronics devices, LED displays we could able to see all over the printers, TV scanner, etc. But in this LED scanner have some defect is, suppose if you take for LED device, if you are making a LED device has been connected in the printer, so the printer shows that red in color. Okay, so while we're making the printout, the red color become pink color, some dull colors. So this is happening in the LED devices. So making of more accuracy and very good accuracy in the color, and especially of making of smart displays and smart devices, so quantum dots are coming into the picture. So the quantum dots we could able to achieve the efficiency matter is 40 to 100%. Okay, so maximum efficiency luminescing of watt with less watt we can able to get more power. So that's a main idea involved in this quantum technologies. So that in this property where we used quantum dots in very different smart displays. So quantum dots have light is this essential role for displays is a good light quality, brightness, contrast, and improved color variations, and high resolution, low weight, and reduction in thickness, reduction in cost, and also the low power consumption. So these are the some of the advantages where we can concentrate on this QLEDs. And this quantum dots also have a property which I told that this having a high color purity, is a very good color purity, and narrow full width of maximum values, high stability, improved color variations, so high quantum efficiency and strong quantum confinement effect. So these are the some of the properties having by this quantum dots, so that people are used for quantum LEDs, right? So how to make the quantum LEDs? So there are some process which involved, there are many evaluations as coming over this quantum LEDs. One is the single layer, 2 layer, 3 layer, and nowadays the multi-layer quantum dots. So that nowadays the people are majority